In this section, we're finding derivatives of trigonometric functions. Let's first remember our basic trig functions. That is, the derivative of sine of x is cosine of x. The derivative of cosine of x is minus the sine of x. The derivative of tangent x is secant squared x. The derivative of cotangent is minus cosecant squared x. The derivative of secant x is secant x tangent x, and the derivative of cosecant x is minus cosecant x tangent x. So our first problem is to take the derivative of this very simple problem. We know that y prime, the derivative of sine of x is cosine of x. The derivative of x squared is 2x, and the derivative of minus 1/2 x is just going to give us minus 1/2. And we're done. So for this next problem, we're going to rewrite it first because we see that we're going to have a product rule here, but we want to rewrite this to have a negative exponent. So we're going to rewrite our problem as f of x is x times the secant of x minus x to the minus 2. So when we take the derivative, we get f prime of x. Product rule says we do the first, which is x times the derivative of the second. Well, that's secant x, tangent x, plus the second, which is secant x, times the derivative of the first, which is 1. And then we're going to subtract off the derivative of x to the minus 2, which is negative 2 x to the minus 3. So our derivative f prime of x becomes x, the secant of x, the tangent of x, plus the secant of x, plus 2 x to the minus 3. In our next problem, we have to use the quotient rule. So our derivative, y prime, is going to be the bottom, 1 plus the cotangent of x times the derivative to the top, which is minus cosecant squared x, minus the top, which is the cotangent of x, times the derivative of the bottom, which is minus cosecant squared x. And that whole numerator is divided by 1 plus cotangent of x, quantity squared. So now we get y prime is equal to minus cosecant squared of x. And then we have minus cotangent of x times cosecant squared x. And then we have minus a negative, so that's going to give us plus cotangent x, cosecant squared x, divided by 1 plus cotangent of x quantity squared. So finally, we get that y prime. These two are going to add to 0. So that's going to give us minus cosecant squared of x divided by the quantity 1 plus cotangent of x squared. In problem 4, we're going to use the product rule. So we're going to get y prime is going to be the first, which is going to be the secant of x plus the tangent of x times derivative of the second, which is going to give us secant x tangent x minus secant squared x. Then we're going to get plus the second, which is secant x minus tangent x times the derivative of the first, which is going to give us secant x tangent x plus secant squared x. So let's simplify. So the first two terms are going to give us secant squared x tangent x minus secant cubed x. Then we're going to get plus secant x tangent squared x. And then we're going to get minus tangent x secant squared x. So secant x times secant x tangent x gives us secant squared x tangent x. Secant x times minus secant squared gives us minus secant cubed. Tangent times secant x tangent x gives us secant tangent squared. And then we're going to get minus tangent secant squared. Okay, we're going to add to that what we get from the bottom, the second part. So we're going to get secant x. So we're going to get secant squared x tangent x. And then we're going to get plus secant cubed x. And then we're going to get minus secant x tangent squared x. And then we're going to get minus tangent x secant squared x. And we can nicely add all of that together. We can see that this term and this term are going to add to 0. And this term and this term are going to add to 0. So we're going to get 2 secant squared x tangent x minus 2 tangent x secant squared x. Okay. In problem 5, again, we have a quotient rule. So we have S is equal to 1 plus cosecant of t divided by 1 minus the cosecant of t. And now we want to find ds dt. So ds dt is going to be the bottom, 1 minus the cosecant of t times derivative of the top. Derivative of cosecant is minus cosecant t cotangent t. And then we're going to get minus the top, which is 1 plus the cosecant of t times the derivative of the bottom. And it's already negative, so it's going to give us a positive cosecant t cotangent t. And that whole thing is going to be over 1 minus cosecant t quantity squared. So ds dt so I'm going to get the first two terms. This term, this is going to give me 1, going to give me minus cosecant t cotangent of t. And then I'm going to get minus negative makes plus cosecant squared t cotangent t. And then I'm going to now have to subtract off a cosecant t cotangent t plus a cosecant squared t cotangent t. And all of that is over my 1 plus cosecant squared t, cosecant t quantity squared. So let's simplify. We get ds dt. So I have minus cosecant t cotangent t, and I'm subtracting off a cosecant t cotangent t. So I get minus 2 of those. And then I have a plus cosecant squared cotangent t, and subtracting off the same term, so they're going to add to 0, and that is divided by 1 plus cosecant t 20 squared. And there's a typo. This should be negative, and this should be negative. Okay. All righty. Last problem is a limit problem. We want to find the limit as x approaches 0. So we're going to do direct substitution. So we're going to get the sine of pi plus the tangent of 0 divided by the tangent of 0 minus 2 times the secant of 0. So this is going to give us the sine. The tangent of 0 is 0, so this is going to give us pi. Over the tangent of 0 is 0, and the secant of 0 is 1, so this is minus 2. So we want the sine of minus pi over 2. Minus pi over 2 is between the third and fourth quadrant. Its sine is -1. And that's our answer.